Hello. In this video, I'm going to go over the decision-making process involved in determining which path you'd want to take when trying to make comparisons between two samples drawn from two different populations. The first question we have to ask ourselves is, what kind of data do we have? Is it a data that is counts of something, measurements or ratios, or is it categorical data where we have individual numbers of elements that are categorized into different properties? If it's the latter category, we can analyze it with the Fisher's exact test. If it's a 2x2 contingency table, with a chi-squared test or g-test, if our contingency tables are 2x2 or bigger. If the data is paired, we have the special case where we have the McNemer test. Now, if we're working with the other type of data, the first thing we want to ask is, are both samples normally distributed? Yes or no. We determine that with the Shapiro-Wilks test. If the answer to that is yes, the next question is, are the variances of those two samples the same? Testing that with an F test. If the answer to that is no, we have unequal variances, but the two samples are normally distributed, then the Welch's two-sample test is the appropriate test we can use to determine whether these two samples have the same mean values or significantly different mean values. If they do have equal variances, then the more appropriate test is the student's two-sample test. If, however, one or both of our samples were non-normally distributed, we have to see whether we can apply a transformation, the same transformation, to both groups, and whether that transformed data has a normal distribution. If we're successful in applying a transformation and the resulting distributions of both groups are both normal, we can then take that transformed data and then go through the step of asking whether there's equality of variances amongst those two groups, and then the decision from there on to use the Welch's test or the student's two-sample test. If the answer is no, if the transformation of both of them does not make them both normally distributed, then we're going to work with the with a non-parametric approach. One question deciding which one's the most appropriate one is asking whether we have similar shaped distributions. We can determine this with the Kolmogorov-Smirnov test. If the answer is yes, they have the same distribution, then we use the Mann-Whitney test to determine whether they have the same medians or not. If the answer is no, then we'd use Mood's median test as a way to determine whether the medians are the same. In Graham Ruxton's paper, he argues that if we have non-normal data, that an alternative approach would be the Zimmerman-Zumbo hybrid approach, where we take all our data points, we rank them all, and then we analyze those ranked values using a Welch's two-sample test. Now, while Mann-Whitney test does have a paired option, and as does the Welch's and the two samples, the Mood's median test does not. And so if you have gone down this path and your data is paired, what you might want to do is do a binomial test, and seeing whether the number of times where individuals from one group are larger than the other, whether that is different than you might expect under random chance, which would be a 50-50 chance. I hope this has been helpful. Good luck.